Let's get some practice working with the standard collections. Now, the standard collections themselves that we've covered in this course are vector, list, set, and map, as well as unordered set and unordered map. I'm going to ask it for exercises involving set and map on the grounds that we've been working with vector for weeks. And list is important, but we got a chance to see it a bit in the last video. And also, it's sort of similar to vector in a lot of ways. There actually are relatively few cases where you really have to use std list. You can use vectors for almost every use that you have for linear sequence, even if in some cases they're a little bit slow. So as far as programming practice, maybe I'm going to have it focus on maps and sets. I'm going to ask it for starter code for all of them because not necessarily always involving writing functions, but I saw in that last video with iterators that it was really nice to have it generate me sort of scaffolding to work within. I want some practice with standard collections in C++20, particularly maps and sets. Can you generate 3 programming, actually I'm going to ask it for 5 because I feel like it's likely going to generate something that I have a problem with and maybe I can just be selective. 5 programming exercises involving maps, sets, and functions which take maps, sets as input. I want some functions involved. For each exercise, provide some starter code. And we noticed in the last video that I have to say not just starter code, but provide some starter code with parts missing for me to implement. Don't show me the solution. All right, let's see what it comes up with. Exercise 1. Okay. Oh no, wait, this is good. I guess I was gearing up to be grumpy because I saw the word vector. Find the frequency of elements in a vector. Okay, well, the word vector throws me off, but I stare at the code and it looks like we're using a map. This looks really good. I love this exercise. I think I may have done this exercise in a lecture already, but I love this exercise, so we're going to do that. Exercise 2, set intersection. Oh, that's a good one. Okay, that's good too. Word frequency counter. This looks a lot like exercise 1. No, it's different enough. Okay, good. Exercise 4, map value sum. Oh, this is good too. These are great. Exercise 5, set union. Okay, so set union is the same as, well, not the same. Set union is very similar to set intersection, but okay, well, I think we can do all of these. The only thing I have a problem with here is I want it looks like it's done functions for all of them. That looks good. I want it to generate its own testing code because in all of these cases, it looks like what we're doing to test is iterating over the resulting thing. So I think we can have it do that for us. I also want a formal specification. Those all look great. I'm really pleased by all of those. Can you regenerate, I'm going to say rewrite all of them to add the following. For each function, add a formal specification in the form of a header comment. It's weird that I can't convince it to do this. And then for each problem, add testing code to main, so that the only part I have to implement is the function. Now, I will admit that in a sense, I am sort of missing an opportunity for practice here because, yeah, writing functions is important. And also, yeah, it turns out that midterm questions are really biased towards asking you to implement functions and giving you testing code. But being able to write test cases is actually a really important skill. So the fact that I'm telling it to do it for me, in a sense, is sort of shirking my responsibility. I need to develop that skill. However, I feel like for these exercises, just for playing with data structures, I think it's better to just focus on the functions. We have plenty of other opportunities to write testing code in this course. Okay, so I'll try that. I guess I better, as usual, say, don't show me the solution. Okay, certainly. Okay, let's see if this is, it looks like it understood what I meant. Okay, so great. I'm going to copy this code. We're going to go and start doing exercise 1. Find the frequency of elements in a vector. Okay, try it again. There we go. All right, so we count the frequency of each unique element in a vector. We get a vector of integers, and then I get a map where the keys are unique elements and the values are their frequencies. I think this makes sense to me. I'll show you what I interpret this to mean. So suppose you give me this vector here. Notice how in the vector there are the following elements. These are the numbers that appear in the vector. I'm just going to write each one once. So there's 6, there's 10, there's 17, there's 111, and there's 116. So each of those appears in the vector at least once. Now, what I think is being requested here is I go through the vector, and for each of the unique elements, I just compute how many times it occurs. So 6 occurs 3 times, 10 occurs once, 17 occurs once, 111 occurs once, 116 occurs once. This is a great exercise for before you know maps. Like, this is the kind of thing that would be a great midterm question just about vectors. Use a vector where each element is a structure with the structure containing the number and the frequency. And the exercise is a great deal more difficult or more, I don't know, annoying if you're using vectors. Maps make this exercise wonderful. Like, it is amazing how easily maps can do this for you. And the reason that it's so easy is because of the way that square brackets work on a map. And so I'm going to write my solution and then test it, and then I'm gonna gloat a bit. I'm just gonna gush about how great maps are. So what I want is to obviously create a map of some kind. So there it is. I'll just copy this definition, and we'll call that result, or yeah, result's a good name. And then eventually I'm going to return that map. So what I'm going to do in the meantime is I'm going to iterate over every element of the vector. And one other thing I'll observe as I write this is before 2011, so before C++11, there was no for each loop. And I don't think there was an auto keyword either. And that means if you wanted to iterate over a vector, you had to use an iterator loop or an indexing loop, neither of which could be done very conveniently. And so this solution would have been a hell of a lot more ugly 12 or 13 years ago. And one of the things about modern C++, a lot of people that don't like C++, the reason they don't like it is because they remember ancient C++ that looked really ugly. A lot of people, when they first see modern C++, and I'm one of those people. So when I first started using modern C++ instead of old C++, I was baffled by how great it was. Like, it was ridiculous how much better it looked. So okay, we'll iterate over every element of my vector AutoX in vec, and then I will, for each thing, I'll say, well, what I want to do is basically go into my map that I'm creating and then increment the value corresponding to the element I'm looking at. So in other words, I want to say result bracket x plus plus, and that's it. Because of the way square brackets work, then if result bracket x doesn't already exist, so if I'm looking at a number that isn't already in there, so suppose 445, I go to deal with 445. So I say result 445 plus plus. Well, if you use square brackets on an element that's not already there, the default behavior is to first add that element with a corresponding value that's the default value of the value type. Well, the value type is int, the default value is 0. And then I do a plus plus on that, and it turns out to be 1. So this, in one fell swoop, either adds the element if it's not already there, or increments its value if it is. So I'll try this out. Okay, it compiled. Practice collections 1. And so in the vector it gave me, we've got elements, so there are 2 1s in this array, 2 2s, 2 3s, 1 4, and 1 5. So it looks like it worked. And this is the place where I said I was going to come back and gush about how great maps are. Look at that! That's way simpler than a lot of the exercises we've done in the last few videos that we're doing something a lot less complicated. This is actually doing a very high-level complicated task, and it's doing it in what really amounts to about 1 line of difficult code. I mean, this is the most difficult line of the function, line 14, and it's not that tough. Line 16 and line 12 are pretty straightforward, and line 13 is just looping over a vector. All of the complexity of the function gets packed into this relatively pleasant looking 1 line of code. Let's do a few more tests. So I'll add a 6, a 10, let's add some more 1s, let's add another 6, and let's add 111 and 116. Oh, and I should do a couple of negative numbers. So there's -1, -1, and 445. All right. Now, because we're actually working with the regular map type, not unordered map, we can actually be guaranteed that when I loop over the elements of the map, and here is a wonderful looking for each loop. I was afraid ChatGPT would write me some old style iterator-based loop for this, but it's written pretty much the same loop I would write. Here's a wonderful for each loop that iterates over the map. When we do that, we're guaranteed to get all of the unique elements in numerical order because it's a map which is, it's not an unordered map, so it has an order. So -1 appears twice, +1 appears apparently 8 times. That looks good. 2 appears twice, 3 appears twice, 6 appears 2 times. Yep, they're the 2 occurrences of 6. And then the other ones all occur once. I think that that's sufficient actually to test this. I suppose the only test case I've missed is what happens if the map, if there's only one distinct element. So 6, or yeah, 6, 6, 6, 6, 6, 6. Just a bunch of 6s. And there's 8 of them. Okay, yeah, that makes sense. And then finally, I guess, what happens if the vector is empty? Because that could happen, and I should expect that the program doesn't crash. It should just print nothing, because there's no element to print out. And it looks like it did that. Okay, so I think I'm done. Exercise number 1. I'm going to bring it back to its initial state. There we go. And then we'll head on over and take a look at exercise number 2. Exercise 2, set intersection. Now, this is wonderful because this is an old midterm question. I mean, I think this is actually on the practice midterm. This is, now, although I should add, sometimes this midterm question shows up, but set, it's not using sets, it's using lists or maps or something. But this is definitely a great midterm question. It's a great exercise to do. So let's do exercise 2. We'll copy the code. We'll head over to a code file. We'll paste it in. Okay, so the intersection of 2 sets, remember that when I'm working with std set, duplicates are not allowed. So I'm going to draw the sets using mathematical set notation. So there's one set, and here's another set, so 2, 3, and 4. And you can see these 2 sets have a couple of elements that they have in common. And the intersection of 2 sets, so if I have this set is called S and this set is called T, the intersection, which mathematically is written with this symbol, is the set of all elements that appear in both. So in this case, it would be 2, 3, the set 2, 3. And the intersection could be empty, or it could be the same size as one of the sets, because it could be that every element appears in both sets, or every element that appears in set 1 could appear in set 2, or vice versa. And so that's what this says. So a set containing elements that are present in both sets. So that's how I'm going to approach this. The way I'm going to write code for this is I'm going to loop over one of my 2 sets, and then as I look at each element, I'm going to ask the question, is this element in the other set? And if the answer is yes, then I guess it's in the intersection. So I'm going to make a variable to store my result. So we'll call this set of ints result. It's going to start out empty. I'm going to iterate over every element inside of set 1, auto x in set 1. And for each element, I'm going to ask the question, is this element in set 2? And before C++20, this was a little bit more difficult, but right now in C++20, I can use the .contains function for that purpose. .contains returns true or false. It returns true if the element you give it is in the set. And so if it is, then I guess it was already an element of set 1, and it's also in set 2, which means it's part of the intersection. So result.insert x, and then I will return my result. So I love this exercise. I'm going to clear my diagram here. Let's go down and take a look at the test case it gave us. So it just prints the set out, and then set A is 1, 2, 3, 4, 5. Set B is 3, 4, 5, 6, 7. So I expect the intersection to be 3, 4, 5. And it is. What other test cases should I use? So in this case, it doesn't make a difference, but notice how ChatGPT has put the elements in the initializer in ascending order. And just in case you feel like that's a little bit suspicious, you could do this. Now, it doesn't matter because, as we know, once the elements are in the set, they're stored in some well-defined order. So, like, sets don't have any, like, you don't have the option of deciding what order the elements are stored inside the sets. They are maintained in something that appears from the outside to be ascending order at all times. But I also want to test out things like, what if they're not consecutive values? So I'll just generate the same numbers I always generate. And then we'll have set B. Let's also, while we're doing this, test out what happens if set A and set B have different sizes. Okay, so it looks like here, I compiled twice. Yep. If I run it, 6 is the only thing that's in both. Okay, so what happens if I have 6 and 445 and 17? Here I expect the intersection to be 6 and 17, and it is. Let's do 6, 445, 17, 111, or 111, 116, and 10. So in this case, set B is now larger than set A, and everything in set A is in set B. And so we get basically a copy of set A. I think that's enough testing for this. So I think we've now verified that it does compute the intersection. I guess we haven't tested. There's one case we haven't tested, which I need to do, which is what happens if the intersection is empty. So there are 0 elements that the two sets have in common. So I'll try that. Okay, so it prints nothing because there's nothing in the intersection. And then finally, what if one or both of the sets are empty? From the code I wrote, I can't see how that would be a problem because we know we can iterate over empty sets. All right, so I think I'm done exercise 2. That was nice. That went by pretty quickly. Okay, I mean, time flies, I guess. So exercise 3, word frequency counter. Count the frequency of each word in a given text. Okay, so, well, I'll copy this and we'll take a look at it. Now, it feels like if I have to spend more time on this exercise, it may not even be for the map. It might just be for the sake of figuring out what words are. Now, I'm noticing a couple of things where I might want to ask for clarification, which is, okay, so the function gets as input a piece of text, so a string. And the goal is to produce basically the same thing as we did in exercise 1. So my thought is, I guess let's do the word this. I want to produce a map whose keys are strings and whose values are counts, the number of times that string has occurred. And to be honest, this is going to require exactly the same code as exercise 1. It's just that before I can run that code, I've got to turn this text into a set of words somehow. I have to extract the words out of my piece of text. There are a few ways I could do this. I could use the getLine function. Interestingly, the ChatGPT has included this in the starter code. Include sstream. And nowhere in this code does it use sstream. That almost seems like ChatGPT sort of has a solution in mind that it's trying to hint maybe to me that I should use. The other thing I have to figure out though is in the sample text in its test case, there's punctuation and spaces. The question is, what counts as a word? Is this whole thing a word, including the dot, or is just the text is that the word? So I'm going to ask it for clarification on that. I think the best way to ask for clarification is just to tell it to give me the sample output. So this is exercise 3. Yes. Can you generate the expected output for exercise 3? Don't show me the solution. All right. So if I stare at this, it looks like I'll actually copy this and we can go look at it over in the template. So if I stare at what it generated, it looks like it thinks punctuation is part of the word. So, okay, the first thing I have to do is verify that this is actually correct in any interpretation. Okay, so the word this with a capital T occurs twice. That's good. The word is occurs once. The word occurs once. The word sample occurs twice. You can see there it is there and there it is there. The word text with a dot at the end occurs once, and that's apparently this. Okay. The word this, okay, this is wrong. So it looks like ChatGPT has gotten very confused. All right. Now I'm going to have to try and ask it a question in English as opposed to just saying generate the sample input. This output is garbage. I mean, this doesn't make any sense. So there are cases where its output could disagree with my interpretation. This doesn't seem to be one of them because this has duplicates. I want to print out the frequency of each word, and yet for some reason there are words that appear, I print out their frequency twice. This doesn't make any sense. And additionally, there's this problem of I've got the word text with a dot and the word text without a dot, but if I count the dot as part of the word, then the word text with a dot occurs once. If I count, and then the word text with no dot occurs once. I can't have my cake and eat it too. Lines 20 and 22 do not make sense together. They don't play well together, so I'm going to assume the output doesn't make any sense. I'm going to tell it that output doesn't make any sense. I'm just going to say that and see if it figures it out. This is what's weird about ChatGPT is that even though it said this, I'll bet if I say this makes no sense without telling it why, it says, oh, you're right. It doesn't make any sense. I apologize. Oh, you're right. So this is really bizarre because it generated the output. I didn't even say what I thought the mistake was, and it went and found the mistake and apparently fixed it. So I'm gonna copy this and see if this makes any more sense. Okay, this occurs twice, is occurs twice, a occurs twice, sample occurs twice. Okay, now it says the word text occurs twice, and you can see that it's apparently not counting the punctuation. And then words occurs once, and contains occurs once. I'm going to interpret that to mean that punctuation shouldn't be counted. And now, to verify that, I'm going to head back over and ask ChatGPT to explain that to me. Okay, so, and again, it's apologizing repeatedly and saying, thank you for pointing out the error. I didn't even say what the error was. I just said, this is stupid. And then it said, oh, you're right, I was wrong. Like, it didn't even check its own work. Okay, so based on that, should I assume that a word is a sequence of not non-white space, of letters, uppercase or lowercase, and that words do not include spaces or non-letter symbols like digits, punctuation, etc. I sort of wanted to say yes, and it did. Okay, good. Now, the reason that I asked a leading question was because I know that it seems like every time I ask a leading question, like, should I do this? It likes to say, yes, you should. And that's because, in a sense, I've learned how to manipulate it, and it's not nice to be manipulative if you're dealing with human beings, but ChatGPT is not a human being, so I'm not going to feel so guilty about that if I gaslight it or manipulate it. So it says, I'm going to assume that a word is a sequence of letters. This pretty much tells me what I have to do to extract words, because that's the difficulty we haven't actually done the exercise yet. The difficulty of the exercise isn't really the frequency part, because we know how to do that. That was exercise 1. It's how do I figure out what the words are inside of the string? And if the words were just any sequence of non-white space characters, I could actually use getLine in a clever sort of misuse of getLine. I would be able to do that. But now word has a special definition that I'm going to need to use my own code for. This suggestion to use stream, I don't think that's going to work now, because stream would be a way, there's an object in there called string stream or string stream, which you can use to extract words from a string, but it doesn't treat a word the same way that we're supposed to. So I'm going to get rid of stream and include cc type. And I'm going to write a function that takes, it's going to return, what do I have here? I'm going to bring in vector. So I'm going to write a function that makes a list of words out of a string. So it'll be called extract words, and it takes as its argument a constant string or constant reference to a string. We'll call it text again. So what I'm going to do here is I've got this string, and it's got a bunch of words in it, and the words include letter characters, and that's it. So there could be spaces, there could be punctuation, whatever. What I'm going to do is I'm going to extract those words by searching for, I'm going to iterate through the string from left to right. I'm going to search for the position of the beginning of a word. What's the beginning of a word? The beginning of a word is a letter that follows a non-letter character. So if the previous character wasn't a letter and the current character is, then I'm at the beginning of a new word. When I hit the end of a word, which is either the end of the string or it's a non-letter character with a letter before it, then I take the word I've generated and I put it in my vector. In the meantime, I'll keep a string for the word that I'm currently picking up. So I'll say string word, and I'll start that at being empty. And then I'll make a vector to store the result. And then when I'm done, I'm going to return the result. So I really like writing loops that iterate over something from left to right once. There are lots of ways of solving this problem. There's a way I can think of that would involve nested loops. There are a bunch of tricks you can use involving parts of the library or other things, or indexing. I like writing a loop that just looks at every character once and just keeps track of any bookkeeping it needs on the fly. So what I'm going to do is keep track of the previous character. So char previous ch. And I'm going to start that off at being a space, because I'm going to pretend that before the beginning of the string there was a space. I think in a previous exercise, I don't think it was a 111 exercise, I think it was one in this course, several videos ago when we talked about strings, I did something similar to this. So if you want more information, go take a look at that video. So now I'm going to iterate over all the characters in my string, so char ch in text, And I want to keep track of whether I'm at the beginning or end of a word. So if ch is a letter and previous isn't, so I'm going to use the isAlpha function, which tells me if something's a letter. And isAlpha is one of the functions in CC type. So if isAlpha on ch is true and isAlpha on previous ch is false, then I guess I'm looking at the beginning of a word. So I've seen a word character after a non-word character. Beginning of a word. Now, otherwise, another thing I could get myself into is what if the current character is not whoops, this should be a not operator. So I want to ask if the current character is a letter and the previous character is not a letter. And then the opposite case is where the current character is not a letter and the previous character is. In that case, I'm at the end of a word, or I'm just past the end of a word. So end of a word, i.e. the previous character was the last character in the word. All right, so to do this, okay, if I'm at the beginning of a word, what am I going to do? If I'm at the beginning of a word, I'm going to set my word string to be blank so that I can begin picking up characters that go into that word. If I'm at the end of a word, then I'm going to take whatever's in that word string and stick it in my result vector, result.pushback of word. Okay, so there it is. There's my beginning, there's my end. All I have to worry about now is being in the middle. And in the middle of a word, or whenever I'm working with a character that does become part of the word, I'm going to do that down here. So underneath my two if statements to handle beginning and end, I'm also going to handle, am I looking at a word character? So if the current character is a letter, so alphabetical, then I add it to the end of the word. Word plus equals ch. And then down here, I'm going to say, I don't think I have to increment anything because I'm just, I'm iterating through the contents of my original string. One thing I'm observing, I'm not gonna do it, but I don't think I need this if statement. I think I could just put word plus equals ch and everything would still work due to a quirk in how these two if statements play with each other. But I'm not going to worry about that too much. I have one more case to handle, which is what if I get to the end of my string and I was just on a word character, and then I hit the end of my string. Well, that means there's going to be a word saved up that I haven't dumped into my result yet. So I'm going to add that as a special case when I'm done my loop. So if word.length is greater than 0 when I'm done my loop, that means that there was a word that I haven't yet pushed into my vector. And actually, that reminds me of something else I have to do in a minute. So I'm going to add that word. Now, I should also observe that when I hit the end of a word, it's a good idea for me to dump out the contents of my word. So I'll just do this. So actually, as it turns out, the way I've written this, I've written it to be overbuilt. I could either delete this if statement and keep this the way it is, or I could actually delete this entire if statement here. I don't actually need all of this logic. Some of it is redundant. And I've got lots of ways I could prune it down, but all I care about right now is getting the code to work. So I've got extract words. I'm going to try calling this and just printing out the result in I'm not going to do count word frequency. I will do it in here. So I'm going to begin by making a map to store my result and then returning it because the program will crash if I don't return something. And then in the meantime, I'm just going to get the words. So I'm going to say auto words equals is initialized to extract words of text. And to begin with, I'm just going to loop over words. So for auto word in words, I'm just going to print them all out because I want to make sure I'm not making a mistake because it's pretty likely, it's pretty easy for there to be a bug in all this code after writing all of it in one pass. So I'm just going to print out the word and then print out a new line. So the map that I return is going to be empty. I've got to compile practice collections 3. Okay, wait a minute. What happened there? It prints out just the letter S by itself. I have a feeling that that's wrong. So we're going to go back up here and see what we can do. So let's think about this. Oh yeah, there is something I missed. So you may recall as I was down here playing with this if statement, I said, oh, I don't need some incrementation, but actually I did. There was something I'd forgotten to do. So the issue is at each step, I'm looking at the current character called ch, which I'm pulling out of my string, my original string, and the previous character, prev ch. The problem is, look at where I use previous ch. It's only when I declare it and when I test whether it's a letter or not. I never actually update it. At the end of each iteration, I have to set the previous character for the next iteration will be the current character at this iteration. So I'm going to try that and see if, I hope that fixes at least some of that bug. Okay, so the text was, this is a sample text. This text contains sample words, and it looks like it is working. It looks like it's generating all the words, even words that end in punctuation or having the punctuation stripped off. I'm also going to see what happens if there's a word at the very end without punctuation after it, between it and the end of the string. Okay, it looks like that works. And then finally, what if I add a bunch of extra spaces? And maybe even a space at the beginning. Yeah, so it looks like it still works. Okay, so I think extract words now works. I'm going to back this all up. Now, once I'm sure that extract words works, I don't need to do that much more testing after I've written count word frequency, because I'm going to use the same code that I did in exercise 1. I mean, it's going to be literally the same besides the type of the result map. I'm also going to make one last observation about extract words here, which is, as I said, this is unnecessarily long. I could delete parts of this code and it would still work. I believe that I could either delete this if statement and have this just sitting there by itself, or I could delete this whole if statement and things would still work. I couldn't delete both of them. I would need to keep one of them in there, but it's just a question of personal taste. But for now, of course, working code works, so let's just leave it. And down here, I'm just going to implement my solution. I'm going to say result at index word, because of course this is a map that takes words, strings, as their key, plus plus. So this is exactly the same as the solution. I'll just show it off. I'll put them side by side. Here is the solution I had to exercise 1. Here is the solution to exercise 3. And the difference is just that I go grab the words and iterate over those. Otherwise, it's the same code pretty much, and the different type of the map. Okay, so I'll try compiling this. I'll just save it, try compiling it. All right, so here's our sample output. This is the output that ChatGPT said I should have gotten. And I noticed that this output that I have is, it has all the same values in it, but it's in a different order. And we have to apply a bit of critical thinking here. Does that mean my code is wrong? And I think the answer is no, because if I'm iterating over this map, which is an ordered map, it's not unordered, that means that when I look at all the words, I should receive them in ascending order. That is, in the case of strings, that would be lexicographical or dictionary ordering. And that also means that I should get words beginning with uppercase letters first, then lowercase letters beginning with the letter A, then C, then I, then S, then T. This is in alphabetical order. Whereas ChatGPT's output isn't, because ChatGPT doesn't actually run code. It doesn't have a compiler. ChatGPT is generating the output based on essentially stuff that it already knows. It's inferring the output. And so it may not realize that this is incorrect, but I think it is. So the output it gave is in the wrong order, and I think my output's in the right order. Okay, that's one thing, but is my output otherwise correct? Is it getting the right counts? Well, the word this with a capital T appears twice. What if I put a word this with a lowercase t? That should be a different word. And a good variant of this exercise would be, see what happens if you remove case sensitivity. So no matter how I spell the word this, capital or otherwise, see if you can make it be counted as the same word. But in this example, it isn't. So capital T this appears twice, lowercase t this appears once. What happens if I add some more words? We'll put a few one-character words in there, so the word appears more than once now. Now it appears 7 times. Now what happens if I use punctuation? So in this case, a word is a sequence of non-letter characters. That means, a sequence of letter characters. That means that this construction here is actually 2 words, this and is. That dash, or that hyphen, doesn't count as a letter, so this is actually going to be parsed as 2 words. That's what I expect to happen. And so I'm going to try this out, and I hope that it works. It looks like it does. So capital T this still appears twice, lowercase I is still appears twice, the word still appears 7 times. Okay, so we'll check our edge cases. What happens if my string is just 1 word? Okay, that appears once. What happens if the string is nothing but spaces? Now it should print out nothing. There are no words. Okay, that works. And what happens if there's a bunch of spaces and like punctuation of some kind, and digits and other various garbage, and then some more spaces and then some more punctuation? I'm just trying all the punctuation on my keyboard. This also has 0 words, and so this also should just print out nothing, and it does. Okay, I think I'm done exercise number 3. I'm going to bring it back to its initial state for testing purposes. There we go. And then we'll head over and take a look at exercise 4. We'll get a compile command for that all ready to go. All right, we'll head over and take a look. Exercise number 4. We'll scroll up to it. Exercise 4, map value sum. Okay, I'm going to copy and I'll look at the specification once I get here. Okay, I get a map which is a map of string to int. All right, and it's provided as a constant reference called my_map. And I guess my job is to add up all the values in the map. This is a good exercise. And we can see here, oh, this is neat. So it's initialized the map using an initializer. And you can see that this helps to reveal that internally we want to think of the map as being a collection of pairs, of std pair objects. And each pair object contains a string, which is the key type, and an int, which is the element, the value type. So what I want to do, apparently, is iterate over this map and add up all of these values. I guess these are like the prices of each item, so cherries are pretty expensive. I don't think it's worth it. What we'll do is just iterate over all of the values in the map and add them together. So I'm going to make a variable to store the sum. We'll start the sum at 0. I'm going to eventually return the sum. And then in the middle, I'm going to write a loop that iterates over the map. And so for this, I'm going to use a for each loop with that unpacking notation. So this is formally called structured binding. So the elements of a map are pairs. And recall that we have this notation that we can use to split a pair up into individual variables. So by writing k comma v, I'm saying take each element of the map, which is a pair, and split it into the key k and the value v. We have to use auto when we do that because the key and value could have different types. So every key and value in my map. And of course, I could call these whatever I want. I can call them value. I could call them key. You're just making up variable names here. And then I just write sum plus equals value. That's all there is to it. This is the right strength to be a midterm exercise. I wouldn't be surprised if I've given this as a midterm exercise before. And what I will observe about this kind of exercise is a lot of people that get a midterm question like this, they might actually know this solution, but they second guess themselves because it looks too easy. They're like, how could this be the answer? It's only, 5 lines long? And then they second guess themselves to the point where they're writing this incredibly long code involving iterators or something because they think, oh, because this seems to be too easy, maybe what he wants is an answer that's full of complicated features. And in some cases, they get a bad mark because they write this complicated solution that's wrong. Don't do that. If the code works, you get full marks. If the exercise is too easy, well, that's my problem, not yours. Maybe it's just that you're too good. It's not that the exercise actually is that easy because this is the usual, I don't know, the old... Right, well, if you notice an edit there, that was because my recording suddenly sort of broke down, I guess. It stopped. So we'll start it up again. As I recall, I think I was talking about this exercise. When you see an exercise like this on a midterm, you might actually think that this is too easy of a solution. Remember, though, that the point is writing working code. If there are other constraints, it'll say so on the midterm question. So let's just try this. Now, I mean, after all of this, maybe it'll turn out this is broken or something, but we'll try it and see what happens. So there we go, practice collections 4. Okay, sum of map values equals 10. Okay, well, for my money, that's correct. 3 plus 2 plus 5 is 10. That looks good. We should do a bit more testing, so I'm going to begin by adding some other values. Let's do a 0 in here. Now, I don't know what the meaning of these ints is. I mean, it maps a string to a signed int. So I don't know whether it's allowed to be negative or 0, but because it doesn't say what it's for, I should test it on those cases. So let's do -5 here. This means it should actually add up to a sum of 0. And it looks like it's doing that. We'll do one more and make sure it adds to a sum of -1. That looks good. Okay, we'll bring it back to its initial value. Let's try adding another item to our map. So we'll do raspberry. Now, raspberries are unfortunately pretty expensive these days. That's too bad. They are worth it, unlike the cherries. I wouldn't pay $5 for cherries. Okay, sum of values equals 20. All right, I think that's sufficient. I think for our purposes, given how straightforward the code actually is, it's pretty clear it is iterating over every single value in the map and that it is incorporating all those values into the sum and returning them. And this also speaks to, I think, how convenient modern C++ is. In old-fashioned C++, so from 15 years ago, this would be maybe only about the same length, but a lot less pleasant looking. So we'll head over. I guess we're done exercise 4, which leaves us only with exercise. All it gave me was 5 exercises, and I wanted to do all of them, so we'll do this one, exercise 5. This is a rehash of exercise 2, frankly, but we'll do it anyway. So this is set union. Now the idea behind set union, let's draw our sets again as before. So there's set union, and there's T. Now earlier we computed the intersection of two sets. Now the intersection, which is written like this, would be equal to just the number 3 in this case. The union of two sets, which is written like this, and you can see the similarity between the two operators because they're sort of, in a sense, they're siblings of a certain type. They're not really a dual of each other, but they model sort of complementary properties. The union of two sets is a new set that contains every element that appears in either set. And we can see that would just be this. So it's like joining the two sets together, except that, of course, duplicates are not permitted. And this is a nice exercise to finish off with because it's I think, even easier than the intersection exercise. So it'll contain all the unique elements from both sets. Normally, the word unique rings a couple of alarm bells because it means we have to do a bit of extra work. If this were the union exercise on vectors, we'd have to write a bit more code. But sets automatically maintain uniqueness of elements. We're not allowed to insert duplicates in a regular set. There's a separate type called multiset for that, but why would we want to use that for this exercise? So set of int, we'll call it s, and then I'm just going to return s when I'm done. All I need to do here is go through set 1 and add everything. So for auto x in set 1, I'm not even going to bother with curly brackets in my loop. S.insert x. And then just add everything in set 2. And if something is in both sets, don't worry, because the set s will automatically prevent duplicates from being added. S.insert x. There we go. Okay, I'm just going to clear my diagram there, and we're going to try running this. That's exercise 4 again, but I'm glad it still compiles. We'll back this up a little bit. Okay, so it's giving the output 1, 2, 3, 4, 5, 6, 7. That's a pretty boring test case. But sure enough, I mean, that is all the elements in either set. Let's try a few test cases where something else is going on. Let's see what happens if one of my sets is empty. Because my code is very symmetric, it feels to me as if this works with set A being empty, I shouldn't need to test set B being empty as well. Okay, so 3, 4, 5, 6, 7, so it's everything in set B. What happens if the two sets contain exactly the same elements? So I expect now the result still should be 3, 4, 5, 6, 7, but just extra proof that duplicates are not being added, and it seems like that's the case. Okay, and then finally I want to test it on a case where the two sets contain maybe some negative numbers, but also where the two sets contain they have a different size. So 1, 2, 3, 111, 116. And we'll verify that that works. All right, and that's it. And that was a great set of exercises. They were all pretty, self-contained and straightforward exercises. They also, I think, demonstrated very well. They were a good advertisement for standard collections because they showed off how easy it is to do these tasks with standard collections. So I really appreciate ChatGPT suggesting that set of exercises. This was a fun video. Besides the part where the recording cut out, this was a really fun video.